going to see mostly, I have kind of two core learning objectives for us. It's to talk a fair amount about how to kind of assess the existing evidence base, including a little bit of a methods 101 kind of crash course, a little bit of exploration of the new evidence scale that everyone's being provided with. And on the other hand, ask this question about when and how you might want to invest in generating new evidence, which is going to be important for a wide variety of programs, since it's actually pretty rare to have a full base of evidence for things that you're doing. And that's okay. But in those instances, we want to make sure that we're investing in new evidence. I see we have a blank screen.
It's showing now.
Maybe I'll just stay in this kind of Gooby format of seeing my slide, but this way we won't run into those problems as much. Is the slide at least still big on your side, Chris?
It's still showing well. It's just showing your whole browser, but it shows up.
Okay. Okay. So, sorry for one more technical difficulty here.
You may or may not be muted, David.
I think I am muted if you couldn't hear me. Okay. I think we're on swing 6 or 7 now. This is learning for how to have Microsoft Teams set up more properly at the start. Thanks for everybody's patience. I can assure you I'm a little more disjointed from this than you probably are now, but let me swing yet again without any skipping of the beat, which hopefully you can see a learning objective slide where I've said a couple of times now, mostly on mute, that we're going to spend some time on how to assess the existing evidence base, but also spend some time on when and how you might want to invest in generating new evidence when it's not at your disposal. And so this begins, of course, with the question of what evidence you actually need, which is in turn a function of what it is that you're trying to accomplish and where is it that you have some information gaps that if you could somehow fill them would tip the way you're making a decision in terms of how you're making an investment, how you're designing a policy. And the new budget template begins with a couple of questions around its opportunities that you're trying to state, as well as the proposed intervention in theory and change, which is really the first and most crucial crux of any kind of evidence inquiry, is trying to make a very clear statement of what it is that you're trying to ultimately accomplish, a very clear description of where you think you are in the state of the world at the moment, and as best of an understanding as you can of the gap between the current and the future state, and why that gap might be there, and furthermore, why whatever program or policy you're proposing is theorized to close that gap down. And so this, for instance, might be something like a project I worked on when I was still in the District of Columbia, where there was concern that the response times for ambulance going out into the field was a little bit too slow, was a little bit below national averages. And so the place that they wanted to go into future state was to have the number of seconds that it took for an ambulance to show up at your doorstep to be decreased. And one of the theories that they had of why this wasn't happening currently was simply having too few ambulances, not enough to keep up with the population growth. And the proposal was to simply buy a few more ambulances. Now, the reason to really slow down and unpack this is multifold. One, the exercise of actually trying to unpack this very explicitly might uncover different ways of thinking about the cause of the gap. A second reason is that you're, of course, advocating for proposals to people who are perhaps not as familiar with your program area. And so taking the time to really explain things that might be obvious to you is important for facilitating others' abilities to assess the proposal that you have. The psychologist in me wants to point out at this place that there's a very common tendency to overestimate how much other people know the things that you do. Psychologists actually refer to it as a curse of knowledge. And so if there are elements of how your program operates that you think everyone knows, don't overestimate that. Take the time to really spell this out. And you might be surprised that it can lead to the identification of different sort of attempts at closing the gap. And in the example I was giving of the ambulance, it actually led to some slightly different ideas around ways of reducing the number of 911 calls that were happening in the first place. And we actually paused for a year on buying too many additional ambulances and instead fielded a pilot where we introduced a nurse triage line on 911, where when you would call, the calls themselves would try to be filtered before an ambulance was sent. And at the end of the day, it ended up actually showing that it reduced the number of ambulance sends, which was a cost-saving measure that avoided buying more ambulances, but also led to better care in the sense of the fit between the type of service a person needed being a little bit better. You don't always need an ambulance. Sometimes you need a more efficient way to get an appointment at a doctor's office, for instance. And so in thinking about the types of metrics that you're trying to move here, I want to introduce at least 4 different types of metrics. And these are quite substantively different, even if the differences are a little bit subtle when you first hear them. And I think they're actually easiest to explain by way of examples. But the 4 metrics are inputs, outputs, outcomes, and impacts. And an input is simply the types of resources that you're putting into a program, the facilities that you're buying, the staff that you're putting into it, equipment like textbooks and things that you're purchasing. Outputs is engagement with those inputs in some sense. It's how many people you've actually served in a program. It's the number of job applications that get submitted through a job training program. It's the number of people walking into your park if you're running a park. Outcomes are the kinds of differences in the world you're starting to hope happen as a function of those inputs and outputs. So an outcome would be something like the actual percentage of people who are employed at any given time, or the sense of well-being that individuals are feeling whenever they're inside of a park. The final category is impacts. And this is actually what people mostly care about at the end of the day. It is an outcome of sorts, but it's one where you've precisely identified that it's some sort of a change in the world that is being uniquely caused by the program or policy that you're implementing. So it's a shift in employment, but it's one that's caused by your job training program specifically. And types of evaluations actually map into different types of metrics. So in the input and output frame, this is where so-called implementation evaluations come in that go out and try to gather a really good descriptive picture of exactly what it is that you're doing in the field, who are the individuals that are participating with your program or policy. Outcome evaluations try to count things that are occurring along with that program, usually over time. I would submit that this is what the sort of state of performance metrics in this state, but across the country, they tend to be outcome oriented. It's following employment rates over time. It's following recidivism over time. And then the third type of evaluation type is an impact evaluation, one that's trying to get at the issue of causation. And this is a one where we really need to slow down. And if you leave this hour together with nothing else, it would be with a little bit of a sharpened intuition about what it takes to be able to make causal claims with confidence. I'm showing you here some hypothetical data of a jobs program that's being implemented at some point in time, and plotted in with the line is the percentage of unemployment. And an outcome metric of looking at something like unemployment rate over time would show a line like this. And the temptation, what's very easy to slip into, is looking at an outcome like the unemployment rate over time and wanting to slip quickly into an assessment or an inference that it was actually caused by the jobs training program that you had. The trickiness on this is that you really need a strong counterfactual to make a claim like that. And what I mean quite simply is some way of clearly thinking about what would have happened had you not done the jobs training program in the first place? What would unemployment have looked like had you not had the jobs program? And what typically happens here is the reason it feels very compelling to think of an outcome metric over time is because we sort of slip into assuming that whatever was happening before in time, the sort of rate of unemployment, would have just continued on the same arc that it was before had we not done the intervention in question, something like a jobs training program. The challenge, of course, is that lots of things are happening over time. And with something like a jobs training program, economies expand and contract for any of 1,000 different reasons, many of which we don't know. If you were looking at something like a crime intervention, there are patterns of crime increasing and decreasing over time. And so this reliance on the assumption that things would have just continued the same over time can cause a lot of problems. Because it could be the case, and this is kind of what I'm illustrating with the purple line here, that had you done nothing at all, the unemployment rate would have started to drop anyway. And when you're looking at it, dropping together with your jobs program, you think it's being caused by the jobs program, but you're actually confounded. You're actually thinking it's that when in fact it was just some other thing that was happening in the background. And in another section of this, we're going to talk a little bit about some of the methodologies that you can use to get a sharper handle on causal impact specifically. Here's one other illustration of how this can get a little bit tricky in thinking about the counterfactual. This is real data from a jobs program. And the question I want you to think about for a second here is who benefited the most from this jobs program? And I'm showing you the employment rate, the outcome metric for youths, adult men, and adult women. Think about this for a half second. And if you're like me in the first intuitive feel, is to infer that youth benefit the most from the program, since after all, their outcome is the highest percentage of employment, 63% versus 57% for adult men or 49% for adult women. But the relevant counterfactual here is actually not comparing across these different groups, but asking the question for each group, what would have happened to their employment rate had they not been in the jobs program? And as it happens in this case, the team that was implementing this program fielded it with a randomized field evaluation where people from different categories were actually kind of randomly assigned, flipping a coin to either be in the jobs program or not. And from that setup, they were able to actually have a control group to look at the employment status of folks as a function of whether they had the program or not. And look at this data for a second. The conclusion here, once you introduce a proper control group, a proper window into thinking about what would have happened without the program, it turns out you get the opposite conclusion precisely. It's actually adult women who have the most benefit from the program. The control group of adult women, 41% are employed, but it boosts up 8 percentage points to 49% if they go through the jobs program. Whereas those youth who look so impressive when you were looking only at the outcome, compared to the control group, actually have the same 63% employment rate. And so this is just another kind of shot across the bow around the importance of thinking very clearly about what your counterfactual is in assessing the impact of your program or policy and why investing in some of those methodologies is going to be particularly important. So how do you find the evidence that you need? To start off with, we're going to have in the template itself a variety of questions that are designed to help you kind of unpack this question. And it culminates in some sense with an evidence scale ranking, which you'll confront first in the template. And this is the invitation to sort of score your proposal on a scale from 0 to 5 on how much evidence is behind it. But you shouldn't jump right into the template and select one of these. This should actually come after you do the assessment itself. And so I'm going to skip for a second to question number 7 from the template, which is a prompt to describe the evidence base behind your proposal, to really unpack the justification for that evidence scale, which means looking at the relevant body of data that's been collected about your program or policy. And so this could include information that you yourself inside your program have been collecting over time. Very often it's going to include looking at studies that were done elsewhere? What are similar programs that have been tried in other states, in other localities, or with similar populations, and trying to see what conclusions they've reached about effectiveness. And so there's a few resources that we point to in the materials. One place that you might want to start your journey is to look at so-called evidence clearinghouses. Really made a whole video on this that's forthcoming, showing how to kind of parse through these. And so I'll just briefly allude to how what you see pulled up is one from Pew, which is taking studies from a wide variety of domains, from criminal justice, education, mental health, public health, and trying to organize them by category, as well as introducing various assessments of the rigor of the study and as well what they found. And so this is a place where if you have a proposal that you're working on, for instance, in the education domain, if you were to go into an evidence clearinghouse, select on something like the education category, you might be able to find the program itself has already been evaluated in some other jurisdiction, which means that you can piggyback on the learnings there and find it quickly. Probably more commonly, you might find programs that are similar but not exactly the same, but this is still a starting point to see what types of evaluations have been conducted as well as what has been found. And so I would encourage you to first and foremost look at these various clearinghouses to see if your proposal is already part of a larger body of work that has been studying it. And again, there's a lot of links and tutorials about how to use these clearinghouses, so I won't spend too much time on it right this moment. And instead, what I want to do is empower you a little bit if it turns out, which could very well happen, that proposal or idea that you have is not in the clearinghouse at all. This happens a lot. In this case, you're not out of luck though, but you're going to slip into needing to do, or someone on your team needing to do some of their own, which you might think of as desk research. And what I simply mean by this is kind of loading up on your computer, searching around and seeing what types of studies or write-ups are out there on a program of your sort. And I've got hyperlinked here again, this is again going to be shared out, a sort of a top 11 tips for doing desk research, because this is something that lots of folks haven't done before, and that's all right. But it's a little bit more straightforward to do than you might think, and you don't need fancy accounts and things like that to do it. The place I would actually point you first and foremost is Google Scholar. Now, Google Scholar is not your regular internet Googles. It's actually scholar.google.com, which if you go to this website, you see your typical friendly Google search browser, but you notice the Scholar on it. And what's powerful about this is that it's specifically designed for searching through published empirical work. And this includes things that have been published in actual academic journals. It's also got a lot of white papers and things in it. And so if you go into here, unlike if you were to do a main Google search, which might put you off in all kinds of different internet cat holes, this is going to focus on empirical studies themselves. And so you might want to study something like body-worn cameras. What's been the published work out there? And Google sort of usefully shows you a familiar search index of results that it's hit. You've got the ability to filter by a few different types of attributes, such as the recency of the publication is probably the main one. And what I like about Google Scholar, on top of just being accessible for anybody who's familiar with internet searching, is that they pop out on the right versions of papers that are freely available. So a disadvantage that you might have that I'm a little bit fortunate to have being based at a university at times is that we have purchased big subscriptions to different journal outlets. You might find yourself getting stuck behind a paywall. Google Scholar is a place where they'll often show you papers that have versions that you can open for free and look at. And so, here's one by a mysterious David Yoakum fellow that you can actually find a freely available study on body-worn cameras. If I were to pick 2 tips to verbalize right here, on top of encourage you just to read through this, it would be the following 2. It would be to refine your terms that you're using to search as you go along. So whenever you start off searching for something in a job program, for example, you might start off very generically with just job program. As you start to look through papers, you might uncover the names of particular programs or technical jargon. Maybe there's a specific type of job program, or maybe you uncover an economist term of art that's used. I'd feed that back into the search engine because it'll allow you to get more and more precise at picking out things in the kind of internet network. The second thing I would encourage you to do is to look through many more pages of the search results than you might think. So in your everyday searching, you might rely on, the first 5 or 10 things that you see and assume that's going to be the best thing. It's not really the way that the kind of academic literature tends to be searched out. In my case, I'll usually do a search and then read through probably 10 to 15 different pages, meaning scanning the titles and abstracts. And by pages, I mean down here, going all the way down to these sort of deeper things that have been indexed by the search. And again, that actually kind of feeds into that first tip I was giving you of just uncovering additional sorts of terms that you might search for, additional programs you might want to search for, additional authors who are writing about a topic that you might want to look for. So between the clearinghouses and some of your own disk research, this is a way to kind of scour out for information. I'll also make a plug here that this is when the office hours can become helpful. So if you're kind of new into a topic and want to ask us whether there's a domain, we might be able to either have somebody on our team who's familiar with the space or connect you with somebody who is, to be able to quickly learn about the space.
I need lots of help. I moved.
Somebody needs lots of help, which you might be asking me, or you might want to mute yourself to not say to the crowd what you need help for. I don't know if that person can hear me. There we go. The music was fun for a minute there, but thanks for muting yourself, and I hope you get the help that you need. What other area, as you're actually starting to read through some abstracts, or you're starting to have a conversation with someone who's talking about the evidence here, is a few tips on how to keep your eye out for study quality. And what I mean by this is not any kind of expectation that you're necessarily going to be going through and really scouring for all the details or having intimate knowledge of all the different methods. But these are a few kind of high-level tips that if any of these features are in place, you might want to ask some harder questions or ask somebody on your team to investigate it more. These are some sort of warnings that there might be a problem with the quality of any individual study or body of studies. So one flag is if too few people are studied. So if there's a study that has a so-called sample size, or it's just kind of collected data from, say, 5 or 6 people, that should make you nervous about how much you can rely on that study, just because there can be quirks of randomness of who those 5 or 6 people are. And the next 5 or 6 people might be very, very different. So for lots of places, one of the features you want to look for is seeing that a program or policy has been evaluated across many hundreds, if not thousands, if not hundreds of thousands of individuals. A second issue is to ask yourself whether the group of individuals who've been studied are actually relevant for the group of people that you have in mind. And so if you're doing something, for instance, where you're uniquely interested in whether a job training program works for recent graduates from high school, people who are earlier in their career in the 20s, and all you're finding are studies of individuals who are later career in their 30s and their 40s, it's not that that latter is necessarily irrelevant, but it should cause you some pause to ask some deep questions about whether the results might be different had those programs be implemented with the younger population. The third one is, of course, causal claims that are being made, but without any clear counterfactual described. So bring back what I was saying before about the issues of, the screen was lost. Thanks, Chris. The third one is if you're seeing causal claims be made, but there's no clear description of what the counterfactual was. So for any study you're reading or for any expert that you're talking to, if they're talking about a crime prevention program reducing crime, you should always be asking yourself whether they're clearly describing in comparison to what. In comparison to if they had done nothing, compared to some other program. And if they're not giving a very clear picture of what that counterfactual is, then it can be difficult to impossible to really make sense of it. And that should be a red flag. A fourth one is if they're not talking clearly about effect sizes. And what I mean by effect sizes is how much of an impact has been caused by the program. So if it is a jobs training program and someone is simply saying it works in kind of a binary sense, that's really not sufficient. What you need to know is how much does it work? How much has the unemployment rate dropped? If it's a crime prevention program, how much has a particular sort of crime been reduced? If it's an educational program, how much has reading self-sufficiency increased? You need that to be able to think clearly about whether the amount of resources you're putting into the program have the type of return on investment that you want. And this is one where I would say that academic researchers, just to beat up on ourselves for a bit, we don't always do a good job of this. We sometimes slip into just providing kind of mysterious coefficients or co-ND. If somebody's not sort of translating it into palpable, concrete ways that you can understand, that's something you should press them on rather than thinking it's a limitation of your mind. So have them translated into something concrete, some way of thinking about how the effect of this program compares to your current programs, or put it in some sort of palpable term. And then this final category is one that I'm sort of alluding to as fishy handling of data, which is worth just a little bit of unpacking of what I mean by fishy handling. If you've not worked with data before, you might think that it is very straightforward to use. It can be this kind of illusion that using data is clearly sort of objective. But it turns out that there's a lot of judgment that goes into how to use data. So if you're imagining a data scientist who's got their Excel file in front of them, there's a lot of examples I could give of this, but imagine something like a row of data that just looks really weird. And so it looks weird to the extent that the data analyst is wondering whether there was a mistake in the entry of the data. And so they make a decision about whether to include it in the data file or instead jettison it out and sort of delete it. And it turns out that for particularly complicated data sets, there are often dozens, if not hundreds of these types of decisions that are made. And the accumulation of those decisions can sometimes affect the ultimate conclusion, whether a program seems to work by this or that amount. And I'm alluding or linking here to an article that I think does a really nice job of explaining some of these issues, called Science Isn't Broken. It's just a hell of a lot harder than we give it credit for. And it talks about a variety of things. One is something that gets referred to as p-hacking sometimes. It's kind of making a lot of decisions in the data in order to kind of put your thumb on the scale to reach the conclusion that you want. It's kind of the example I gave a minute ago about decision about whether to include a row or not can sometimes fit into this. A second is something that gets referred to as a file drawer problem. So this is instances where a result is perhaps not favorable, or it's not the thing that the researcher wanted. And so rather than publicizing it, they don't go out of their way to talk publicly or to publish that result. They kind of stick it away in the file drawer. And that can cause problems too, because if you see in your search for the literature, for instance, that 20 studies were done, but only 3 of them are being reported on, you should have a little bit of a yellow flag going off in your mind about what happened with those other 17. Is it the case that perhaps they found a different result and didn't publish it, but those results will be really relevant for understanding the sort of cumulative body or cumulative state of the evidence? And in the article itself, if you go out into it, there's a little app here that can give you an intuitive feel for what I was talking about for the p-hacking sort of dynamic. This is an interactive data set that asks the question about whether the US economy is affected by whether Republicans or Democrats are in office. And it gives you a bunch of little things you can select off and on about the data. So by the question of Republicans or Democrat in office, well, what are we talking about? Presidents, governors, senators, people who are in the House. When we talk about the economy, what are we talking about? Employment, the GDP, stock prices. And what's interesting about this is if you go in here and play around, a lot of these kind of subtle decisions about how you're defining things can change the result that you get. And so as I'm switching, for instance, GDP as being included in economic performance, under this setup where I'm not including it, it looks like there's no relationship between who's in power and who's in office. It's kind of flat line, there's no significant result. But if you take out GDP, then suddenly it turns out that there is a significant relationship. And in this case, Democrats have a negative effect on the economy. And so the lesson from this is to be sort of vigilant to look out for the types of decisions that people are making about how they are in fact doing their data analysis. And the one other thing I might advocate for here, particularly as you're planning evaluations that are more forward-looking, is the prospect of trying to make a lot of these decisions about how you're going to do the analysis before you know the impact that it's going to have on the results. And this sometimes gets referred to as writing up a pre-analysis plan, or a plan for how you're going to sort of do the analysis before the data is sitting there itself to actually crunch. I've linked here, if you want to look at it after the fact, to an example of a pre-analysis plan for that body-worn camera study that I alluded to, as well as another one that we've been doing here in Providence and some other places. And it's a way of trying to actually bring people together who are going to care about that study to reach agreement on the methods that are going to be used before everyone knows what output happens as a function of those methods. So it's a way to help avoid some of the fishiness. So a quick methods crash course on some of the methods that you're likely to see. And this is coming off of a question from the template around the types of methods you currently use for program evaluation. There's another question asking about which ones you might want to use in the future. They do roughly map to those types of metrics I was describing before. So measurement of the resources that are going into a service or initiative, those inputs I was talking about. Measurements of how many people are using a service, either because you're sort of clocking that data yourself, or maybe you send out surveys to ask people how often they partook in a program or what they thought about a policy. Those are examples of measuring some of the outputs. Outcomes, which can also be partly gauged with surveys and things like that, as well as data like monthly or quarterly reports of student test score, average of wages, crime reports. These are examples of outcomes. And then these final two categories of measurement of causal impact have two main categories, one of sort of econometric metrics, which I'll say more about in a second, and randomized controlled trials, or RCTs. Why, by the way, do I clump some of those self-reports as not in the impact category? So these are places where you're just asking people whether they think they've been influenced by a program or a policy. I'll tell you, I find this type of data incredibly useful, but it's largely for purposes of understanding how people are engaging with the program and generating some ideas of how it might be impacting them. But you really do need to start to splice in some of those additional methods if you want to make strong impact claims. And the basic reasons are one of a few things. One is if you just ask people how they were influenced by a program, they may answer in ways that really fit into what they think you want to hear, as opposed to what they really think. So this could be trying to avoid saying something embarrassing. You know, if you're asking about questions related to sexual behavior or tax evasion, it can sometimes be they're not wanting to criticize a program. So if it's your program and you're asking them what they thought of it, you know, it can feel kind of mean to say it didn't work for me, as opposed to saying, oh, it was great, thanks so much, this has changed me forever. A second reason is that even if people are being very, very candid, it turns out that reporting on why we do the things we do can actually be pretty tricky. So I've got an example in the footnote here of a study that we did at the federal level, for instance, that simply changed the location where somebody signed their name in relation to where on a page they were reporting how much they owed in taxes. And it turned out that if they signed before they went to that little data field and typed it in, they reported a higher amount. And it wasn't because most people were actually trying to be dishonest. What it seems is that having that prompt before they enter the field just caused people to be a little bit more vigilant and precise. So we saw the numbers that were getting reported, for instance, went out to more decimal places, were a little bit more precise by $6 here, $15 there. But if you instead asked that signature question at the end of the form, that effect didn't occur because people had already filled out the question and didn't bother to go back. And that's an example of a pretty subtle change of behavior, and one that if you ask people whether they think they'll be influenced by the location of a signature, we know that they tend to say that they won't, because it's very subtle, and who would have thought that would happen? But if you measure it as we did, you can actually uncover it. A third reason is that just memory is faulty. People can forget why they've done the things that they've done. And a fourth problem, if you ask just a handful of people, is that you might run into that same kind of sample size problem I was talking about before. If you don't ask enough of the right sorts of folks, it's difficult to make a generalization about the overall population. So for all of these reasons, it's not that these qualitative methods aren't really important. They're just providing more exploratory information or information about inputs and outputs. If you want to get into some of the more causal methodology, here are 6 common types. I'm not going to talk in detail about each of them, but the 6 are randomized controlled trials, natural experiments, pre-post comparisons, regression, instrumental variables, and regression discontinuity. Let's pick just a couple to talk a little bit about. Starting with randomized controlled trials, or RCTs. These sometimes get alluded to as kind of a gold standard causal methodology. And what happens in this typical setup is you take a group of individuals and you split them up in a random way. And I mean that in the sense of kind of flipping a coin. If it's a heads, you go into a job program, and if it's a tails, you don't. And that coin flipping, that randomness, is the really key critical ingredient to a randomized controlled trial. What it does is it creates 2 groups of individuals that on average you would expect to be the same in every conceivable way that you can then compare, such that if you see any difference in the metrics that you're measuring at the end of the day, you can infer, basically as rigorously as scientists ever can, that it was actually caused by the one and only one thing you've caused to be different, namely whether you have in fact assigned them to that program or not. And so an illustration of this, to go back to this body cam study that we did in DC, is one where each individual police officer, by the flip of a coin, was assigned to wear a camera or not. And to kind of prime your intuition pump here about why the randomness is so important, imagine the other types of ways you could have constructed the group of officers with cameras or without. You could, for instance, have asked for volunteers, for cops to come forward and volunteer to wear a camera. Well, in that case, the thing you might worry about is the type of officer who volunteers might just be different than the type of officer who doesn't, and different in ways that actually matter to metrics you care about, like how likely they are to use force or have a complaint. Maybe it's your more proactive and so sort of better officers that are volunteering. And if that was the case, the cameras might look like they're having a positive impact, but in fact, what you're really measuring is just that underlying difference in the type of officer who's willing to volunteer. Or say you just compared the trend over time. Here again, this is a place where maybe you see use of the force go down over time, but it could be difficult to know whether that was caused by the camera suddenly being rolled out or by any number of other things that changed in the background. And in the district, in fact, we had a lot of things happen in the background. We had laws change, we had a new chief of police come into the district, we had crime trends that were changing. Both of those types of counterexamples, and a lot of other ones I can give, aren't problems with the type of coin flipping that I was talking about. The coin flipping is kind of a great equalizer. When you do that coin flip, for instance, you get an equal proportion on average in both groups of the type of person who would be willing to sort of volunteer, right? So if you think about all those individuals who were volunteering, if you're flipping a coin, some of them are going to get the heads and go into the body cams condition. Some are going to get the tails and go into the control condition. With the coin flipping, the time dimension doesn't cut in the same way either, because we have, at the same point in time and moving forward, a group of officers both with and without cameras that we've constructed through the coin flipping that are experiencing all those background things at the same time. Both groups experience the change in the police chief. Both groups experience the changes in laws that are occurring. And so the coin flipping, that randomization, is kind of the great equalizer in ensuring that all those things happening in the background, including importantly the things you don't even know about, are equally represented in the 2 groups. And again, the one and only thing that's different between those 2 groups is the things that you've controlled to be different, or in this example, whether an officer is wearing a body camera or not. A natural experiment is a shorthand for just something that happened to have occurred that essentially is the same as if you were to have designed a randomized controlled trial yourself. So an example of this might be any program that has more people applying for it than you can actually fit into the program. And so you do something like administer a lottery to decide who goes in. And so, for instance, there's been a lot of studies of public versus charter schools that have just relied on the fact that there's more students wanting to go into one or the other than who can fit. It's a sort of natural experiment because which school a student went into was random in the sense that a lottery ball was drawn. These pre-post comparisons I've talked about at a couple of terms now. This is looking over time. I don't have much more to add here to say other than to just hit one more time that these can be risky if you're assuming that a trend that was happening was going to just stay at a constant change. That's often not the case. And so you almost always need to do something more to be a little bit more sophisticated than that. And then the last one I was going to say just a half second about is regression. This is actually one of the most common types of studies that you're likely to encounter. It's, I think, the case because there's a lot of data sets out there, and economists and other researchers often will try to kind of squeeze information that they can out of those data sets. And here's the kind of output that you'll often see in studies of these big tables with different coefficients on it. You might see statements around how the regression was significant with these R squares, these significant p-values. And these can be pretty gnarly to try to interpret, even for me at times. And if you're not familiar with it, it can feel very, very inaccessible. But the roots of a regression are actually not that complicated if you just slow down on some of the core basics. Which my 2-minute version of this would be to sort of help invite you to think about it as trying to draw a line between some data points. And so here's an example of an equation. You might remember this from high school. It's kind of the equation for a line. Where in words, this is asking a question like, how can we predict how much a person is likely to weigh if all we know is something like how tall they are? And this weight equals 115.8 plus 8.6 plus height in inches. That 8.6 is the so-called regression coefficient. And all it's telling us in words is that, all else equal, with each additional inch of height that a person has, we're going to up our prediction of their weight by 8.6 pounds. And if you didn't know anything about a person's height, you would guess that their weight was this average 115. And so with regression models, what they do when you hear people talking about a model is they've got all of these different predictors, and the numbers that you see in front of anything like this height at inches is telling you kind of all else equal with each incremental increase of whatever that is, height in inches, or maybe it's the gender of the person, maybe it's how old they are. The coefficient is how much that prediction is going to change. And the reason I refer to this as a line is that if you do something like draw a scatter plot of how high different folks are and how much they weigh, where each dot here is a person. Here's a person who's 68 inches and they weigh 120 pounds. What a regression tries to do is draw a single line that fits through all those data points in a way that minimizes, in the aggregate, the distance between the line and all those different points. It's trying to draw a line that comes as close as possible to being as close to as many of those points as can be. And that's a little bit of a difficult concept to just wrap your head around in words. And so I do drop here another invitation after the fact to go and follow this link to a little applet that lets you play around with how these lines get made. You can kind of go in here, drop a bunch of dots for different data points, either, for example, different heights of folks, the different weights. And then you can click to fit your own line and sort of play around with what's the shape of this line that best goes through all of those data points. And then you can select display the actual line of best fit, which is the answer. And you can see here, my intuition was not very good. But this is what a regression line is actually trying to do, is draw a line that minimizes those different points. It's easy to draw with a single predictor, like something of height predicting weight. That's just drawing a single line through here. I could even show it to you with two predictors. If you were to imagine a three-dimensional sort of chart, so maybe this is the person's height and their age, and trying to predict their weight, you can kind of imagine a plane that's moving around on a three-dimensional field. And then, of course, there are regression models that throw in all kinds of stuff, 3 and more. And this, you cannot visualize in your brain. You can't actually show it in a graphical sort of way, but the concept of what a regression is trying to do, of sort of drawing that line through all of the points, is still the core of what's happening, even with more complicated regression approaches. And the reason I think it's worth it to sort of build your intuition on these kind of simpler models and play around with those applets is to motivate kind of 2 key tips, at least, for how you might try to digest regression results, either if you're reading them themselves or if you're having someone else speak to you about it. One of it is to make sure that either you're yourself or whoever is relying on the regression slows down to actually just look at the data. And the importance of this is you can throw a data set into any statistical software and punch some buttons to run a regression, and it will pump out coefficient data. It will just give you data. And if you don't slow down to actually look and make sense of whether it is a reasonable approach to try to draw that line through it, you could very easily mislead yourself. And one illustration of it is to look at these 4 panels I've shown here, which are regression lines that are all exactly the same, but 4 very, very, very different types of data patterns. That leftmost one is the kind of even spread that makes a lot of sense. But look at that data set number 2, where the data kind of pops up and down. It turns out that the regression line through that still is the same, or you could have something like the far right data set, where the vast majority of people have the same value around that sort of 7 point, but there's one big outlier that still weights the direction of that line in a way that looks very the same. This is the kind of thing that if you were just to look at a big table of coefficients, you would never pick up. But if you actually just look at the data, you could pick it up. And so again here, the upshot is, in my experience, the people who think the best about the data really don't jump to the really, really fancy outputs first. They instead ask to look at and do look at just pictures of data, really descriptive things, and then ask themselves whether those more sophisticated things mesh with some of the more accessible, intuitive understandings they have of the descriptive and visual data. The second big thing to ask yourself is whether all the relevant predictors are included in the model. And what I mean by that is, I gave you a simple example of just using height to predict someone's weight, but these regression models are only as good as all the different predictors that are in there. And in this case, we know that weight is going to be predicted by a lot more things than just height. Things like the age, how much a person exercises, what their diet is, all of these various variables, if they're not accounted for, are going to lead to models that don't predict as well. And so for studies that you're looking at that are doing these kind of regressions, you need to ask yourself whether they're being really, really thoughtful about their decisions of what to include in the models or not. And often it's not the case. One key example of this, I think, is a tendency to just throw in some easily accessible demographics, things like gender, socioeconomic status, and race, and sort of call it a day. But of course, for lots of programs and policies, those things often matter, but there's often a lot of other things that matter as well. And if you don't get right those inclusions, your model can be deeply misleading. And it's precisely actually the challenge of knowing what you should include in the model. What are those things that you don't even know to think about? That is, again, another reason that the randomized controlled trial is often the appealing method to use if you're able to, because it doesn't actually rely on explicitly unpacking all of those predictors. Instead, go back to how I was describing it, it instead relies on the randomization to assume that all of those features, all those different attributes, even the ones you don't know about, are going to be equally represented in both groups in such a way that the differences kind of wash out. And again, the only thing that's remaining as a difference is the one thing you've controlled to be different. All right. That concludes the sort of evidence 101. The evidence scale, which, to jolt your memory, is a sort of 6-point scale from being theory-based to proven effective, as well as a 0 here of a place that there might actually be growing evidence, but of, unfortunately, an insufficient or unintended effect as a 0, is a tool that is meant to help you think about where you might be on this evidence continuum. So as you're looking at the body of studies that have been done and the rigor of those various studies, this is a moment to sort of step back and ask yourself whether the accumulation of all of that, where it sort of places you on this continuum. And so, for instance, with the body cam study I've alluded to a couple of times, when we started that back in 2013 or 2012, there were really almost no studies of it. There was one study that had been done, but it was a pretty theoretically based intervention where we knew from other psychological research that people tend to behave differently if they're being observed. It also sort of made intuitive sense that if there was video evidence of an encounter, that could be used after the fact for disciplinary or training purposes. And so it started off as a theory-based intervention that we put into the field. But we coupled it with evaluations like the randomized controlled trial that I was mentioned to start building up evidence to be able to move up this continuum. And so if you flash forward to 2020, we've now done a study, and there's actually 30 or so different studies that have been done, including a wide variety of randomized controlled trials that have allowed the accumulation of evidence to start to move up on the scale. And so the way you should approach this is less of worry about the scale being used as any kind of like decision tool of only proven effective are going to be funded or only theory based. It's really meant to just help facilitate thinking about what we currently have as our confidence on whether something's going to work, and where it's only theory based or perhaps promising, which is actually probably going to be most of the programs and policies that we're seeing. Having that raise our awareness that we might want to think about investing in the generation of additional evidence so that this time next year, this time in 5 years, our overall placement on the evidence continuum for different programs and policies is increasing. And so to that end, my last little stretch here before we pause for some questions and discussion is to raise back to the top of our minds when and how you should, in fact, generate more data than you're able to find from the clearinghouses, from your own desk research. And it begins with a simple question of what still don't you know that matters, and thinking about this evidence continuum. I'm putting the inputs and outputs and outcomes and impacts back on here because, again, these build off of each other. And if you're at the stage of a very early program or policy that you're putting into the field for the very first time and hasn't been tried elsewhere, then you're likely in a state where the most important investments you're going to be making is really ensuring that the implementation is well, making sure you're capturing the right metrics in terms of what those inputs and outputs are, and making sure that the delivery of the program is happening in the way that you want them to. If instead you have a already well implemented program and you don't yet have good metrics on the outcomes, that might be the place that you need to make your next round of investment. It's looking for areas where you can start to gain better information about the employment status of people who've gone through your program, or better data about how much people are enjoying a park, or better data about how safe people are being on roads after your new signage. And then finally, if you have good outcome metrics there, if you haven't yet gotten a really clear window into that counterfactual of what would have happened had you not done that, or if you don't have a really good handle on what effect size is being sort of uniquely caused by your program, then the importance of an impact evaluation starts to come front and center. And this is where the question of how much you should invest in this, again, just turns on how important it is to really have a solid handling on the impact. But it's in this instance, at this kind of more advanced stage of the evidence continuum, that those econometric and randomized controlled trial methodologies that I described are more likely to come in. And there's a few more questions in the template that are going to help you think about this, or for us to talk about it if you come into the office hours. Again, there are just an explicit prompt about what methodologies you're thinking you might want to use, as well as a few questions related to the type of data that's at your disposal. And so one of them are types of data, whether you have qualitative data, quantitative data, that's that kind of big split between whether you're asking people their self-reports of things versus whether you're measuring something like how many people are coming in the door of your program. You might have at your disposal different types of data in terms of being aggregate or individual level, by which I mean perhaps the only thing you know from any particular school is the percentage of students who qualify for free or reduced lunch. Or maybe you have the actual raw data where for every individual student, you know what their income level is. And you might have some differences to look at this question 12 on whether you have data that is being specifically and deliberately collected for evaluation purposes, or it's being collected for administrative purposes. And the value of really asking these different versions of data quite explicitly is to help identify places where you might be sitting without even knowing it on really rich data that can help you move up the evidence continuum. And so my prior slide here on the opportunity for sort of low cost randomized trials or evaluations is a plug that it's not uncommon for people to think that doing these types of evaluations necessarily has to be something that takes 5 or 10 years and costs $1 million. In my experience, that's simply not the case. We actually have a lot of examples now of places where you can often learn quite a lot with the information that's at your disposal now. the body cam study, I've alluded to it several times, for instance, the main metrics that we looked at were data that were already being collected. So there were already a lot of records being generated for uses of force, for instance, because they use them to investigate cases, complaints as well. And what we did is we relied on that existing administrative data so that the kind of marginal cost of that study was really only my time and graduate students. It was around another 50 or something $1,000 to learn quite a lot about a program that was costing millions of dollars. And so this is a plug to say that even if you don't have a big budget for evaluation or you're not really sure what information might be at your disposal to make that next kind of move up the evidence scale, there might be more opportunities that you think. Answering this question and coming to the office hours is a way to help think about it. It's also where these final questions around partnership opportunities come in. So very just directly asking whether you're already working with anyone who's got some experience in these types of methodologies and whether you might be interested in some additional consultations here. Again, this is meant to be pretty low stakes at first. It could just be a simple conversation to see if there might be a fit or value in pursuing some of these. If it turns out that there is and you're not sure how to find the right folks or how to structure those partnerships, that's another place where we have a kind of a bank of individuals as well as examples of how to structure those partnerships that we could talk about. And so with that, I'm gonna round it out by just reminding that this kind of crash course on evidence is one part of a lot of different resources. There's the longer budget instructions themselves. The decision package template itself is meant to be kind of a decision aid for you. There are some documents that some are out and some are still forthcoming around examples of better and worse types of responses to the templates. And again, office hours that are happening daily, both with OMB as well as myself and other from the policy lab. And as we tip into the discussion, I'll also just say this is, as y'all know, the first time we're trying out a lot of these different templates and different resources. And so very much looking forward to and appreciate any feedback you have, both now and at the end of the day, on what's worked and what's not. We're very excited to keep making tweaks on the margins here to make this as helpful as possible for everyone involved. Okay, with that, I'm going to try to turn off my screen share so that I can see you guys and invite questions and discussion.